Hello everybody, this is Max Hipko with G4 Geomatic Resources. Today we're going to be looking at Cyclone 3DR for reality capture applications in construction. Specifically, we're going to be doing a ASTM standard floor flatness, floor levelness analysis and report. I already have a project imported in here and there's a lot of data, but all I'm going to do is turn on the main point cloud here. So we got a multi-story structure. This is one of the slabs. You can see this is beautiful point cloud data from the RTC 360 with beautiful imagery and colorization, point density and accuracy as you would expect. So we're going to be using this point cloud to go through a floor flatness analysis and produce a report, both visual and PDF. So up at the top we have this analysis tab. We're going to go over there and you'll see the FFFL analysis workflow tab. Now it's grayed out because we have to select the point cloud. Once we have that selected, this is now an option. Click on that. What's going to pop up is this ribbon, so you have a clearly defined workflow and guided wizard that's going to bring you through this. First being extracting the floor. Simply, we're going to pick a point on the plane that we want to use. So I'm just going to pick a nice point out here, nice open, not on any debris, not on a column wall or anything. You can see it does kind of an auto extraction. Bringing it down, what we're going to do is we're going to hit compute. And what that's going to do is that's going to trim it down above and below to even closer to that plane as much as we defined over here in the extraction tolerance. I have that set as 1/10 of a foot. So it's going to take a little bit to process that, but it shouldn't take too long. And what it's going to do is it's going to bring all this high projection up in the point cloud down closer to that plane that we picked out earlier. And you can see that's done. So we have a nice closer to just plain flat plane surface to work with. You can see the results over here, the amount of points extracted. Next thing we're going to do is we're going to hit next. We're going to be defining the test surface. All we're doing is simply picking the area of which we want to run the analysis on. Over here you see contract specifications. I'm not going to change any of these because I don't have a specific contract to work with. This is just a demo. But these would be contract specifications, again, included in your contract. So please input them if that's the workflow you're doing. But what we need to just do is define the area we are working with. So we're just going to simply plot a nice square area for this purpose. Once it turns green, that's basically telling you that you can do the analysis on. It's going to give you all your parameters. If you're good with all that, we can hit next. Next is going to be define test sections. So if we wanted to subdivide this into multiple sections, we could. For the sake of this demo, we're just going to use the entire test surface as the test section, but just know that you have that capability. So let's hit next. So now, if you're used to the ASTM standard, this should look pretty familiar with you. We're just defining the sample lines. So you get some options over here. You can do parallel, perpendicular. You can click and add, take away lines. I'm going to do 4 with 45 degrees. What you can do though is you can also select individual lines, and you can see as soon as they're green, they're basically within tolerance and distribution. When they go orange, they're too close. When they go red, they're either out of bounds or just not proper. You can also use hotkeys to change the length and place them. Once you're good with the distribution, and once the wizard tells you you can complete an analysis with this distribution, your compute button will become available. So we'll hit compute, and it computed our values. You can see there's a couple high spots and low spots. It's probably just debris and stuff sticking up off the floor and needs to be cleaned up. But generally this is a pretty flat section. A little high spot over here, a little low spot over here. And at this point in time, if you wanted to go back, you could reset. You could go previous and adjust this if it wasn't meeting your expectations or what you're trying to get out of this analysis. You can edit all these colors and values, but we're just going to keep it the way it is for now. So we can hit next, and it's just going to give our final results. So it's the standard is for each cross-section line, it's going to give us our information. Over here it's going to give us our results, and based on the contract specifications, these may have an X next to it, meaning they're in or out of tolerance. And you can turn off these labels. You can add more labels and measurements to this as well. But essentially you've completed the whole floor flatness, floor levelness analysis wizard according to the ASTM standard. So now we can exit the wizard. And now you can see in 3D we have the results plotted right on our point cloud. So great visual representation if you're trying to go over deviation results or things that need to be corrected or shifted, reporting in a visual sense if you're working with the cloud. But what's a nice tool is also this report tool up on the tab. So we can hit a report and we can generate a floor flatness report. So all this can be customized to your analysis and whatever your contract is. So we're just going down here and you can see floor flatness, floor level analysis. You got all the results in here in the PDF as needed, and you can add and edit all these values. So that is how you complete that wizard, and it's a very powerful tool and just another great way to use point cloud data in your construction, engineering, and analysis projects.